Now let's look at the converse of the triangle proportionality. I can't say proportionality today. Well, I just did. Triangle proportionality theorem. And let's see, let's go back to just the triangle proportionality theorem itself. It says if a line is parallel to one side of a triangle and it intersects the other two sides, so if it's parallel and then intersects the other two sides, then it divides those sides into segments that are proportional. The lengths are proportional. Now the converse of that says if a line intersects two sides of a triangle, all right, so here we see a line intersecting two sides of the triangle, and if those sides are proportional, in other words, if AB is proportional to CB, then the line is parallel to this third side, AC. In other words, then ED must be parallel to AC. So that is the converse of triangle proportionality theorem. So if we got a line, it's intersecting two sides of a triangle, and if those two sides are proportional, if we can get a common ratio or scale factor, let's say, between those two sides, then we can prove that in this diagram here that ED is in fact parallel to AC. Now, if they're not proportional, then they're not parallel. We still have the situation where it intersects two sides of a triangle. It's just not parallel to that third side. So we're going to take a look at one here, and we're going to try to determine if we can prove parallelism. All right, so here we've got a object, a diagram on the right, and we're told that this is triangle DEF. DEF. And DG is 1/2 of the length of GF. All right, so this then doesn't look like it, but this would be 1/2, and this would be 1/2 of whatever that total length is. DG is half the length of GF. All right, so we got a scale factor of E of 1/2, and EH is 6 units, measures 6 units, and HF measures 10. And then we're asked the question, is DE, is this segment, DE, is it parallel to GH? Well, according to the converse of the triangle proportionality theorem, then DF and EF, those two segments, they must be proportional. Well, if DG over GF equals 1/2, then for those two lines, DE and GH, to be parallel, then EH and HF would also have to equal 1/2. So let's see, EH we're told equals 6, HF we're told equals 10. Well, if I reduce 6 over 10, I'm going to get 3/5. I'm not going to get 1/2. And so then I can say that no, DE is not parallel to GH. And how do I know that? Because the converse of the triangle proportionality theorem tells me that if GH was parallel to DE, then DF, the parts of DF and the parts of EF would have to be proportional, and they're not. Now that's having a good time.